Roy, what's this thing sitting in the shop?
This is a double wall vacuum insulated vessel for storing liquid hydrogen.
Oh, it's a big thermos bottle that stores hydrogen?
It's a big thermos bottle that stores hydrogen, lets you take hydrogen as a dense cryogenic liquid, vaporize it on demand to fill vehicles or use as a delivery for an emergency response with our TESI.
So how much hydrogen can be stored in this size container in a liquid form contrasted to the
we can store
like this compressed bottle in here?
Well, with modern technology, I'll just tell you the ultimate. With modern carbon technology, we can store hydrogen more densely than the liquid can store hydrogen.
Right.
You can take a volume of liquid and store much more, as it turns out, on an adsorbed basis on carbon.
Well, how about this though? This is liquid hydrogen. How does this size container here compare to the one that's how much?
That would refuel this tank about 4 times.
That's all.
That's right.
So in a liquid form, this is only equal to about 4 times as much as that is at 3,000 or 5,000 psi.
Well, it depends on the pressure, of course, but you know that's why I say
about 4 times.
About 4 times.
Now there's bleed off on here too, right?
Yes.
It won't hold the hydrogen forever.
Oh no, well this is going to give up hydrogen all the time. Now this could go to a TESI or it could go to some other application, but it's always going to be giving up hydrogen because it boils off as it's gaining heat from the outside.
What's the temperature of the hydrogen in there?
It's minus 421 to about 423.
Minus 421 degrees Fahrenheit. That makes
a very large delta T across from ambient.
That makes the Arctic look like a
warm place.
The surface of Venus.
Yeah, it makes as it turns out, a very good reference to superconductivity. So you can store liquid hydrogen and have superconductivity out of known materials.
What's absolute zero? Minus 460. And we're at minus 420, so we're 20 degrees above absolute zero.
That's right.
That's cold.
That's pretty chilly.
But we can make that. Well, how long ago in history was it we could liquefy that temperature?
Oh, about 120 years ago.
120 years ago, we could make liquefied hydrogen.
That's right. Even during the Civil War, it was discovered that you could make hydrogen and make very cold gases by taking heat out of compressed gases on a repetitive basis to cool them to the point of liquefaction.
So again, this is not cutting edge technology. This is something we've had around for a long time.
It is.
Great. Now here's one of the fuel sources that could be used for one of these TESIs.
This is a engine generator and a supply of heat that's left over from the generation and engine operation for any of the purposes that we've given before. It can cook food, it can provide space heating, it can provide a sterilization of other water, and it can provide condensate from the hydrogen combustion.
So at one time this was a standard Generac 2000 series generator.
And now it's a hydrogen emergency delivery system.
Does this have the cooking surfaces in it and everything?
Well, no, they come right on top when it goes together.
Oh, so here's part of it. It gets bolted on
That's
at
right.
the destination.
It goes right on top.
So you can then cook in this, recover the water.
That's true of all these TESI units. For disaster relief, they go to do whatever is needed for the crew.
So this is actually a much older Onan generator.
It is.
And this has been converted as well.
And it shows the ability in this regard to go quickly on a flatbed, arrive and be assembled with the ovens and cooktops and condensers and start making potable water.
This part of your fuel intake right here?
Well, it's part of fuel mix. This runs a high boost and can run a mixture of a number of fuels. If it is true that at the disaster that the only thing that they have are petrol, we can go back and run petrol.
So again, the thing to take away from this is basically part of the conversion unit to run on hydrogen, high boost, or a combination of fuels. We're not talking about rocket science and things from Mars. We're talking about changing the fuel-air mixture going into the throttle body system, into the air intakes, and this thing runs.
Practical rescue of communities that are stricken by disaster.
Or everyday use.
Or everyday use to rescue their economy.
Or my personal economy.
Or your personal economy, your farmstead, your homestead.
I want more money in my wallet.
Sure. Well, and you want it to be an anti-inflationary event that brings it. In other words, you want to make a market pull for farmers and other entrepreneurs to bring the hydrogen and the carbon to markets, carbon as a durable goods development product.
So the same way that we saw the carbon that made the bottle, we can use the carbon to make our house.
Make countless things.
We can make the concrete,
That's right.
make our
Stronger.
sandals.
Make
We can
countless.
make your shirt.
Virtually all the durable goods can be made stronger, lighter, more fire resistant,
We can replace this with carbon.
and make it much safer for the occupants.
We can replace this with carbon.
We can produce this largely out of carbon.
But isn't there a lot of carbon in there too?
That is true, but the carbon that we could get for this purpose will be an anti-inflationary use of the carbon.